suggesting that possibly all of the grass species are part of the same created kind. That's big. That's 9,893 species of grass in the world, including bamboo, by the way, and corn, and wheat, and rice, and all of this sort of thing, okay? This is all in this family. The research is still going on, but it looks like the family, what we're now calling families, biological families, is probably very close to the biblical kind. If that's the case, now there are some where it's bigger than the family, there's some where it seems to be smaller than the family, but on the average it seems to be coming out about the family, which is fascinating because of all of the classification levels. The only one that's got a name that means something like relationship is family. Species, genus, family. Order, class, phylum, kingdom, realm. How did that work? Most interesting. It has to do also with the vagaries of history and amazing things like the wrongness of, what's his name? Augustine again. Not Augustine. Aristotle. Aristotle did the genus and species thing. He gave us that. And then it gets messed up with time. But anyway, if that's the case, if it's at about the level of the family, the average size of the mammal family is about 100 species. So that means within 200 years of the flood, we've got to produce, on the average, about 100 species of mammals in each created kind. The average plant family is in the thousands. So the average plant has to increase in 1,000-fold in the same 200-year period of time. Insects, average family size is in excess of 1,000. So they've also got to diversify 3 orders of magnitude in the course of a couple centuries. The Arphaxadian epoch just would have been one cool time to look for critters. Because every day when you opened up your tent, you'd see a new species. But it's not just because you saw a species you didn't see before. You're seeing a species that's never been here before. It was born this morning, okay? I mean, these are new. This is amazing. This is cool stuff. It reminds me, there's a couple organisms on the current planet which might actually be in this current diversification mode even now. I read a book a couple of years ago. It just tickled me. There's a guy working his PhD on the fish, on the cichlid fish in Lake Turkana in Africa, which is where we get most of our fish in the fish tanks, the cichlids who we like in our fish tanks. He's identifying species. So he goes out and he's got a net and he drags a bunch of fish in, and new species, new species, new species, old species. And he goes into shore, identifies a new species, and goes out the next day and hauls in a bunch of new species, new species, new species, old species, and goes back in and identifies them. And he's writing this book, and he's going through several weeks of this. He's out there in the boat one day and he pulls in the net, new species, new species. New species. New species! He concludes at the end of the book that he was so exasperated because he believes, honestly, and you can test this statistically with rarefaction analysis and so on, you can actually estimate how many new species you should be able to find every day. And it should decrease and logarithmically as you go along. And it wasn't doing that. It was remaining, once he had developed the technique, for any given technique, it would rise until it hit a certain level and then continue constantly. It would be a linear increase in the number of species per unit time. He used a different method. It would have a different yield, but it would hit a linear plateau. It was not stopping. So he deduced that new species were being generated every day in there. He thought they were being done by crossing of extant species, by hybridization. But it could be that the cichlids are actually undergoing right now that diversification which characterized most species on the Earth's surface soon after the flood. So it'd be really interesting research for creationists to do to work on these kind of places. There are a couple of species that appear to be, or groups, that appear to be doing this even now. And if we're ever going to figure out how this works, it's probably best on something like that. Now, That having been said, I need to also say that it isn't that you're getting a bunch of different colored finches. It isn't that you're getting a bunch of different small variations in dogs. Within the camel group, for example, you're getting llamas and camels. Camels are extraordinarily well designed for the desert. Those desert designs are not displayed in the llamas. Okay, suggesting that there's some big changes that actually come in here, not just a whole bunch of different color combinations that are pretty stuff. You know, and besides the camels, in the camels, there's a camel that's very much like a giraffe in the fossil record. There's a camel that looks very much like a hyena in the fossil record. There's a camel, there's some really big differences in camels in the fossil record. Really big differences in the horses in the fossil record, much more than in the present. And then there's some clues in the present of even bigger differences. Here's a group of plants that Todd Wood worked on as an undergraduate and then a graduate student. Flavaria is a genus of plants in which you have some species that are C3 photosynthesis species and other species that are C4 photosynthesis. Now the difference between C3 and C4 photosynthesis is really quite amazing, actually. In C3 photosynthesis, which is, we'll call it normal, most plants use that AB photosynthesis with the C3 system. The entire photosynthetic process, about 500 chemical steps, occurs within each cell where photosynthesis actually